Swayam Prabha. Digital India. Educated India.
So, welcome back. Let us start today's lecture, lecture 3 of module 1, which is the continuation of clay products. So, what will be covered in this is basically bricks made with alternate materials. So, it is a shift from clay, but as alternate material, what are the alternate materials that help in making also called brick, and then we will go back again to the clay items of terracotta, porcelain and stoneware, clay roofing tiles. So, brick, as we have all understood, was the building material, the basic material which most of our country or developing country like ours are using, but it is a lot of depletion of our natural resource. At the same time, we need to look into the wastes, how we can take care of them and whether we can use them up in form of this tablet or brick. Fly ash is one such waste product which is coming out after combustion of pulverized coal. It is very fine, finer than sand. It moves around in the atmosphere in and around a thermal power plant generation area. It pollutes the atmosphere too, but it is collected in ash ponds, wherefrom it can be carried to a brick making area. Following the similar principles, it was tried or evolved as an alternate building material replacing clay brick. So, it is little lighter than clay brick, it absorbs less water, it is machine made and dried in controlled environment, and you remember no burning is required. Hence, it is energy intensive. It is less energy intensive, sorry. At the same time, it is consuming a lot of waste material. And even if you see the thermal conductivity, as it was of brick up to 1.25, here you see the thermal conductivity is 1.05. So, that is, it is thermally better. So, it is resisting the thermal energy to come inside. So, it is resistive, it is better than brick in that quality. Now, why has this been and why will people select it? So, the government, as I have told you of the codes, standards in my initial lecture, all bricks used within 100 kilometer radius of a thermal power plant are to be fly ash bricks. That is been declared by the central government in India, obviously. So, here what are the advantages? It is energy wise less energy intensive, it is using up the raw material as the waste as its raw material, it does not take so much of time, it has to be dried in a controlled environment and then you can sun dry it. These are molded from machines, as you can see in this picture taken from Gava fly ash big factory in Kharagpur. You see the fly ash which is lying has been converted to this brick. So, lot of construction is being done by this fly ash brick. It has become popular and gradually it is at par in price with clay brick. Earlier it was coming much cheaper. That was also a sense why general people did not buy. They thought it is cheaper because it is inferior in quality, but it is not like that. So, fly ash brick is one such item, and here if you see the ingredients, fly ash is around 60 to 80%, and you see rest is sand and cement of which is around 8 to 10%. It may also be replaced by lime, because cement or lime is the stabilizer which helps the items to become one. So, these are mixed with desired amount of water to get the desired consistency, molded, control dried for 24 hours within a factory shed, and later on put under sun and then ready for site. So, you can see the strength here, it is as good as a second class brick. Weight is almost like that of a first class brick. However, clay bricks may be little weighty. Fly ash brick maintains this 2.6 kg weight, and its use is similar to that of clay brick. You may plaster it, you may not plaster it, because the water absorption, I think it is not mentioned here, it is also up to 15%. Now, I introduce to another item, which is since 2005 our Auroville Earth Center has experimented with earth blocks. So, this is compressed stabilized earth block in form of bricks or in different shapes as required. This is moist, nothing but moist earth or clay, what we call, under high pressure around 20 Newton per square meter pressure. They are becoming building blocks. They are having much lower embodied energy as compared to even fly ash brick and also clay brick. It has low carbon emission. As fly ash brick flies around and creates lot of pollution, here the clay fired brick is also creating lot of fuel burning, which leads to carbon emission. This compressed stabilized earth block is only using pressure to make it a stable earth item, clay item, and you see the compressive strength is also between 5 to 7 Newton per square millimeter, which is also quite good. Water absorption is varying between 5 to 20% depending on the type. As you see, there is class A and class B, and Auroville Earth Center has lot of experimental items or buildings within its premises, which are demonstrating that compressed stabilized earth block is also a building block which can replace fly ash brick or maybe clay brick. So, with these all, I think we are over with all the types of brick items, brick items which are the basic building block. Let us move to terracotta. Maybe some of you are familiar with this kind of image which has been displayed here. This is the facade of or entry of a temple, and you can see lot of ornamental works being displayed, and this is facing the inclined weather. It is standing for few hundreds of years and nothing has been damaged. Why so? The ingredient is not just clay. Clay has been supported with ground glass, crushed pottery, that is broken pottery items, which has been grounded and used, and clean white sand. So, with clay goes, which is the maximum percentage, with which goes ground glass, crushed pottery and white sand, which again mixed very nicely many a time in the pugging mill and then molded out with this ornamentation on it. And with this ornamentation, the entire thing is put into the muffle furnace and is being burnt. Because of adding glass, it gives an impervious layer or coating on top of it, and it allows not to absorb water. It has very low water absorption, even less than 12%. It is very hard and durable. As you can see, it stands for years together. This is very rich ornamental part. It has to be made uniquely for one building. So, obviously, the price is higher. Some items may be obtained, some decorative items may be obtained, terracotta plates may be obtained, so that you can put it in some entry to emphasize or make it grand. So, it can give you a heritage value to it, because these were used in our temples. But mass scale production of terracotta is maybe no more practiced. You can use it, you can use templates, you can make it as per your order, and then only you can use it. So, ornamental parts of building, it finds its use. Facades of temples, it finds its use. Sometimes it is entrained with air to make it porous, and you can have porous terracotta. You can have further amount of glass, and you can have glazed terracotta, and you can make use of this terracotta in the way you want and place the order as per your desired space, desired facade where you actually want it. Now, let us move to the other two items, the porcelain and the stoneware. You can see the pictures on your left hand side, the wash basins, the cisterns, the commodes, the water closets, the sinks, that is all the sanitary fixtures are having a glass like coating on top of it, and it is seamless, it is very smooth. It has, why is this used? Because it has antimicrobial property. It does not carry stain. It is not affected by acids and alkalis. It has a permanent coating on top of it, which is the glaze, and you see it is made of china clay, feldspar, kaolin, silica and clay baked together at a high temperature to achieve vitreousness. As you had seen brick going up to 1100 degrees centigrade or so, these items are baked further at higher temperature to get the quality of vitreousness, vitrification. Some 1400-1500 degrees centigrade, these are baked to get vitrified. Vitrified, once it is vitrified, it does not absorb water, and this glaze on top of it becomes transparent, and it gives an impervious look or imperviousness characteristic to the item. Vis-a-vis, we have stoneware, which is refractory clay, which is silica and alumina, and along with, you see the term is there, stoneware, you add stone dust and crushed pottery as we had used in terracotta, and you can bake it to a high temperature again to achieve vitreousness and low porosity. It will be hard, compact, strong and durable. The points are written for you. You can see this culvert pipe. These are all stonewares are used where it is resistant to weather, where there is chances of stain or chemical action. You can put stoneware, they are not much affected. They are not so porous but even not impervious like porcelain, and these are mainly used for underground services, underground water services, because you cannot replace it as and when required. It won't come to your notice even what has happened there. So, these are hard and compact durable items which are put underground, underground sewer line. You can use stoneware. So, it can take any pressure on top of it. So, it won't break and it is quite durable, and some sanitary wares are also made with stoneware. Another item which I have not put into the slide is earthenware. Those are not so stable like stoneware, but they also find their use in not much in building industry, but also some in piping. Now, after we finish with all the items, we come to the last one, under clay tile, which is under clay is clay tile, and particularly clay roofing tile. We have flooring tiles, we have wall tiles which are also made of clay, but we will cover that when we are into glass and ceramics. So, what you see here, this clay roof tile is used as a unit to cover the roof. When you go along countryside, you can see such kind of images. It is usually sloping, as you see in this section, and the most important point is they are much thinner than brick and they does not take much load. Yes, one human load, two human load, 2-3 people can go on top of the roof for some repair and replacement work, but it cannot take load. So, you cannot have a independent floor on top of it. It is only to protect you from rain and wind. So, it is the covering or the roofing. What you had seen, brick was created for walls, but here it is made for the roof. It is usually in an inclined position, and these are unit by unit interlocked. In case of brick, you had to add them with mortar. Here clay tiles are not added or fixed in nature. They are interlocked and are replaceable. Say one of the tile gets damaged, you can replace that with a new tile. So, now how are they fixed? If you see this picture, you will see something is happening here. So, a tile may vary across the country. It may have different shapes, but the principle remains same. It has a supporting member or a nib that will help it to hold or cling that is called the nib. Hold it to cling with the purlin or the framing system. I will come to that, I will show you a better picture. And you have two holes which are called the nail holes, which runs through and through, on which you can screw it with the support onto which it is clinging. This nib may be continuous, this nib may be piece. So, this is the base of the tile what I have drawn, and that is the top part which you see, the below. So, this thing is actually like a claw, it is holding the vertical member, the frame, and sitting there. So, what I drew is a very flat tile or a pan tile. Across country you will see Mangalore tile, half round tile and various names, various forms, but you have to remember there is an interlocking arrangement. I had drawn the flat tile. So, how is the interlocking happening? Let us see in the next slide. So, if this is the framework, your tile is sitting like this and your next tile is sitting like this. So, how are you starting? You are starting your tiling process from the base, from the lower, and you are moving to the higher, because you cannot pick up this and place this one. So, you are placing your lower tile first and then you are topping with the upper tile, and below is the frame. Maybe this is the wooden frame onto which it is clinging. So, how much will this go? This tile will actually have to protect the nail hole. So, here is the nail hole. So, the next tile should start from here, so that no water can enter into the system, into the room. So, you have to remember this upper tile should cover the nail hole and it must drain all the water to the next and again next and again next. And at the end you must have a special gutter system which again will be supported, which will collect the water, here, which is coming down and gets drained. So, no water can enter here and disturb the or allow water entry into the building. Now, what happens on the sides? You will see so, when you are getting the view, you are seeing only this circle thing with a very small gap which is allowing the water to flow. But actually the tile starts from here and goes till there, again it starts from here and goes till there, where the lower part is not visible. It may be sometimes under tile and over tile, it may be something like this and something like this. So, this may be one tile and it is supported with an over tile. So, there may be many types. So, on the side there is again a interlocking method adopted, so that water does not leak into through the roof. So, on this side you are having a tight interlock, on this side you are having like a claw an interlock, and the over tile, the upper tile is covering the nail hole, so that no leakage is happening. So, your roof becomes watertight. And any kind of replacement required. As I told you, these are not capable of withstanding load. Even a hitting of a stone can make it break. So, you can actually move it, take out the nail holes, and you can replace the tile. What happens at the top when it is ending? As you had something called the eave tile, specially made to eaves gutter. Eaves gutter as a special tile. For the ridge or the top, you can have a special ridge tile, so that no water can enter through here. So, now this sits on the frame which I had shown you. So, let us go back. So, this is the frame. Now, how are these frame to be fixed? You have to know what is the locally available tile dimension. Based on that, these wooden supports called purlins are to be fixed, and these are the common rafters onto which they are to be fixed. And here comes the ridge, here comes the ridge tile, here end comes the gutter tile, the eaves gutter, and in between these you will get your tiles. Now, here you see a further detail, you can see the nail hole, and you see the upper tiles are one on top of other. Here also you can see the same thing. So, this is a very indigenous way of doing. All our countrysides, all our rural India still uses it, they are using it, and they can replace it, and they can have the repair of it, and can have a weather resistant or a proper roofing to their house. With all these, I conclude with the clay items, clay products, and also the alternate materials used replacing brick. The various other clay products that we studied are the terracotta, the porcelain, the stoneware, and the clay tile. Clay tile, under clay tile we understood how it has to be fixed. Similarly, we knew in case of brick how bricks are to be arranged to get brick masonry. Here we understood how clay tiles are to be placed to get a proper weather resistant roofing. So, we conclude here with clay, and thank you to all.